Hi everybody, this video today is going to be talking about 6.1, which is a basic review of exponents. We have done a little bit of exponents in this class before this year, but we need to go a little bit more in depth, and so we're going to go through some concepts we need to know. First of all, this is just like a definition. The base is the number, like the big number, and the exponent is the power. And so when we talk about exponents, we're talking about just that little thing, and the base is the big number. So that's the deal. So for instance, that's important because where the negative is and also where the power is make a difference. And so in this case, this 4 is really only on that x. It's not on the 2 or the negative 2. So the negative is like separated out, and then it's just each of these x's multiplied together. And so we can see we have 4 x's. We still have our negative. We still have our 2. So that's negative 2x to the 4th. However, on the next one, we have some parentheses. The parentheses shows us that the whole thing is the base, that the 2x is being taken to the 4th power, but not the negative. So like when I write it out, for instance, I have a negative out here, but then 2x times 2x times 2x. So my negative stays. 2 times 2 times 2 times 2 is, I wrote 8, but it's actually 16. So let's make that into a 16. We're going to change that. Negative 16x to the 4th, because 2 times 2 times 2 times 2 is 16, and then 4x's altogether is x to the 4th. And then lastly, what if the whole thing is in the base? Well, if the whole thing is in the base, then you multiply that base every time. So it's negative 2x times negative 2x times negative 2x times negative 2x. And again, it's not 8. Negative, 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 negative. That is 4 negatives. That's going to give us a positive. And then 2, 2, 2, 2, that is again 16, and then we have 4 x's. And so it's just important to notice where the negative is, where the power is, are there any parentheses? You just have to pay real close attention to that. All right, how about properties of exponents? You might have learned these as little shortcuts, and the reason I don't like the shortcuts is I want you to know what's really happening. So x to the third times x to the second is like x times x times x times x times x. That's 5 x's altogether. And so we have x to the 5th. What we're going to do here is we're going to go through the examples first, and then we're going to fill in the rules later. Okay, x to the third to the second power means x to the third times x to the third. That means x times x times x times x times x times x. There are 6 x's there, so that is x to the 6th. Next one, we have parentheses with an xy that is taken to the third power. That means xy times xy times xy. That means we have x to the third and y to the third, because we have x, 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 that's x to the third, y, 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 y to the third. Negative powers. Okay, let's come over here to the margin because I don't have enough space to talk about everything that we need to in here. So the negative exponents go to this and this. So 2 to the negative third is this one. So 2 to the negative third, well, let's think about 2 to the third. Well, 2 to the third is 2 times 2 times 2, which is 8. But when we have a negative power, we have to flip it upside down. So 2 to the negative third is actually another way you could say that would be 1 over 2 to the third, and that's going to be 1 over 2 times 2 times 2, and that's 1 over 8. So 2 to the negative third is 1 over 8. And then this other one, 3 to the negative 2, similar concept. 3 to the second is 3 times 3, which is 9. And 3 to the negative second is like 1 over 3 to the second, so that's 1 over 9. So that one's 1 over 9. Okay, and again, we'll fill in the right-hand side here in just a minute. Quotient of powers. Quotient means divide or fraction. So when we have division or a fraction with powers, what do? Well, we have 7 x's on the top. We have 2 x's on the bottom. 2 of these x's are going to cancel with 2 of those x's, and it's going to leave us with x to the 5th. Power of a quotient. And again, a quotient typically means division or fraction. So if we look at a power of a quotient, again, I'm coming over here. So let's kind of pay attention over here. 3 over 4 to the second power. That's what I have here. It means 3/4 times 3/4. When you multiply fractions, you multiply straight across. That's 3 times 3 is 9. 4 times 4 is 16. So 3/4 to the second power is 9 over 16. There's other ways to think about that too, which we can get into, but for now, let's just call it that. And then 3/4 to the negative second is 16 over 9, because when you do it, you flip it upside down. So I showed that over here. 3 over 4, and this should probably be in parentheses, to the negative second power means flipped upside down and do it twice. So there we have it. And then last one, anything taken to the 0 power is 1. Anything in the whole wide world, take it to the 0 power, the answer is 1. Okay, now we've been over some of the examples. Why don't you take a minute and fill in some of the rules? And so these might be rules you've heard of before, or maybe not, but maybe you can come up with them from here. So pause the video, and then we'll go over the rules. Okay, let's go over the rules real quickly. Yes, when you have a third power and a second power, you add those together. 3 plus 2 is 5. So anytime you see a multiplication with powers, you just add the exponents. Okay, the next one, a power of a power, we multiply. 3 times 2 is 6. And so anytime you see a to the m times n, or to the nth, then it's a to the m times n. You multiply. Power of a product, basically, it's like you distribute that 3, kind of. So you kind of go like that. That's x to the third, y to the third. So anytime you have a power outside there, then you just distribute that m onto both of the variables, or whatever is inside there. Negative power always means 1 over. So if we have a to the negative n, that means 1 over a to the n. Quotient of powers, you always subtract. Yes, it's 7 minus 2 is 5, but we have to think about where those x's going. So that's why I wanted to show you that. But that is how you do it. You just subtract those two numbers. Power of a quotient, we multiply the whole quotient times itself, the whole fraction times itself. And if it's a negative, we flip it upside down. So another way to think about this is 3 squared is 9, 4 squared is 16. So yeah, you could basically kind of distribute that m to the numerator and to the denominator. And anytime we have anything to the 0 power, it is 1. Okay, we're going to now spend some time working through some examples that use those. And actually, before we do that, we're going to do a little bit of scientific notation. Scientific notation, this fits in here because there's powers. But what you really do is on your calculator, you really just multiply like these numbers, like the first numbers together, and then you deal with the powers second. So I'm going to show you on the calculator, if you multiply 8.45 times 6.72, you get 56.784. So this is going to be 56.784, yikes, that's a 4, times 10 to what power? Well, in between here, there's a times. We multiplied this times this, and we got that. When we multiply 10 to the 5th times 10 to the 9th, we just said when you do that, that was this first one. When you multiply those two things, you're supposed to add the exponents. So we're going to add those exponents, and that's going to give us a 14. And then the only little thing is in scientific notation, we really don't do tens places. You really only do up to the ones place. So you really need to move that over. And so you get 5.6784 times 10. Now, if we moved it over 1, then what do we have to do here? Well, if we move this over 1, we have to increase this one by 1. So that is 15. All right, same thing over here. Take a second, find your calculator, multiply these two numbers to see what you get, and then we're going to add those two exponents together. Okay, when I multiplied those two numbers, I got 17.6897. So that's going to be 17.6897 times 10 to what power? Well, 7 plus negative 4 is third power. But I need to move it over because I only want the ones place. So I'm going to get 1.76897 times 10 to the, well, I had a third power, but I moved it over 1, so I have to increase this 1 to compensate for that. Okay, that's how we do scientific notation. Let's turn the page. We'll do some examples of powers. Okay, when we do these kind of problems, we've got a bunch of numbers and variables and everything going on. I group them together. I look at them piece by piece. So in other words, 4 times 2, that's 8. I'm going to look at my x's. X squared, x to the third. My rule that we just learned says that that should be x to the 5th. All right, y. Y and y. Remember, that's like a y to the first, so if that confuses you, you can put a 1 in there because that answers me y squared. And then z to the 10th. So you just go piece by piece, you multiply each little part together. All right, this one's a power of a power, though. So that one, basically, the rule was we're going to kind of distribute this power onto all of those. What's that going to give us? Well, I'm going to take it step by step still. So that's negative 2 to the third, x to the negative third, and y to the sixth. Now, I'm not done, but what I've done is I distributed that. There might be some confusion here with the negative sign because it's not very clear. Does that need to be taken to the third power? It does need to be taken to the third power because it's inside the parentheses and the 3 is outside the parentheses. So that's going to be still negative because negative times negative times negative is negative. So that stays negative. So we have a negative 8. This x to the third needs to go to the denominator. Anytime you see a negative power, it needs to switch either numerator to denominator or denominator to numerator. And then y to the sixth goes on the top. All right, so that's our final answer on that one. Okay, part C, anything to 0 power is 1. That's easy. Part D, we want to simplify, just like I did, like numbers and then x's and then y's and then z's. Same thing here. My numbers, 2 goes into 12 6 times, so that's a 6. M to the third, m to the sixth, well, 3 of those cancel with 3 of those, so 6m to the third is my final answer. Okay, in this unit, we have a lot of rational expressions. Those are fractions. So I want to have some practice with those. Well, this is easy. Anything with the 0 powers is 1. So that's 1 over 2ab. We're done. This one is a second power. That 2 essentially gets distributed to all 3 parts. So that's going to be 4 squared x to the 6 over 2 squared. Okay, well, 4 squared is 16, x to the 6 over 2 squared is 4. 4 goes into 16 4 times. My final answer is 4x to the 6th. And with these, I have to say, there's a lot of different avenues, like what do I do first, what do I do second? There's a lot of different ways to do it, but either way, any way you do it, you should come up with this answer. Okay, this one though, please excuse my dear Aunt Sally, says we have to do the exponents and the powers of the parentheses first. So this is going to give us x to the 5th, y to the 3rd, but I still need to multiply that by xy, so that's going to be x to the 6th, y to the 4th. That's my final answer there. When I have these like this, I like to go all the way across the top and then all the way across the bottom. So when we go all the way across the top, we have a to the 4th, b to the 2nd, c, and on the bottom we have a b and a c. And now we have to look and see what cancels out. Well, these c's cancel, and b goes in here and cancels that, so there's just one b altogether. So my final answer is a to the 4th times b. All right, 2 more examples. These involve negatives. Negative powers. We have a negative power we have to flip upside down. So this is like x to the negative 16th, and x to the negative 16th is 1 over x to the 16th. And on this one, oof, man, there's a lot going on. So much so that I'm going to take it step by step. The first thing I'm going to do, a negative power on the outside means you should flip everything on the inside. So I'm going to flip this. 3x to the 3rd, y squared over 2x negative 1, y to the 4th, z to the 0, with a 2 outside. Okay, I flipped it. Since I flipped it, it's not negative 2 now. Now it's just a regular 2 because I flipped it. Now I'm going to go ahead and kind of distribute that power to all 3 parts and everything down here. So that's 3 to the 2nd, x to the 6th, y to the 4th. On the bottom, 2 squared, x to the negative 2, y to the 8th, and z, 0 times 2 is still 0. 0 times 0 anything power is 1, so that's just times 1, and 1, we don't really need that in multiplying problems, so we can cancel that out. With the y's, we have 4 y's up here that cancel with 8 over here to leave me with just 4 left over. With the negatives, you have to bring it up. So this is, or you could think of it 6 minus negative 2. So 6 minus negative 2 is 8, x to the 8th. So what I have now is 9 x to the 8th over 4y to the 4th. Again, there's lots of what should we do first, what should we do second. So there's other ways to do that, but that's how I'm getting that answer. Okay, that's the end of this video, and we will pick up on the next page next time.